Bullitt Lecture in Astronomy. My name is Jerry Villiger. I'm an Associate Professor of Astronomy here at University of Louisville. And tonight we have the honor of listening to Dr. Chris Stanek from The Ohio State University. I had to put the "the" in because it's my alma mater as well. Who will talk to us about measuring the size and age of the universe. But before then, we would like to thank some of the individuals and organizations who made all of this possible. And having a lecture series go for 12 consecutive years is an achievement. So first of all, I'd like to thank Mr. Lowry Watkins Jr. for funding this lecture series and for other funding for astronomical studies at the University of Louisville. We would also like to thank Mortarboard National Senior Honorary and the Society of Physics Students and the Louisville Astronomical Society who helped put up posters to advertise this event. Are any members of those three organizations here? Please raise your hands. We thank you very much. You have helped to promote scholarship at the University of Louisville. So the William Marshall Bullitt Fund has given support to this lecture series. William Marshall Bullitt was the Solicitor General of the United States under President William Howard Taft, and he was also a very keen amateur astronomer, a mathematician aficionado, and he was also a lawyer by profession, a learned man who did many, many things. And in his honor, this lecture series has been bestowed. One of the other parts of this lecture series is the awarding of several scholarships to students who have excelled in the study and the promise of study in astronomy. And so we would like to invite Mr. Lowry Watkins Jr. to present the certificates for these awards. So the first two are going to be undergraduate students who have excelled in the study and the promise of studying astronomy. So I'd like to ask Mr. Jared Keown to come down, please. And also Mr. Blake Pantoja. And Jared and Blake are undergraduates in studies in physics and astronomy here at the University of Louisville. And they have excelled. This is for Mr. Keown. And this is for Mr. Pantoja. The faculty of the Department of Physics and Astronomy made a committee to evaluate the various students in the department, and we consider them to hold great promise for future studies in physics and astronomy. No, that's fine. I'll be the MC. So let's give them a hand. They are future astronomers, the seed corn of astronomy from the University of Louisville. Please don't sit down if you're going to be awarding one more. So we'd like to call down Miss Karen Collins, who is a graduate student here at the University of Louisville. Karen Collins is a PhD student here. She did her bachelor's degree at Georgia Tech in engineering, and she worked as a professional engineer. She did her master's here in astronomy, and she was my student, and I made sure she worked very hard. And now she's doing a PhD with Dr. John Kielkopf on detecting exoplanets. And she has won the award for the best paper in astronomy. So she co-authored a publication in the Astrophysical Journal. It was peer-reviewed, which meant that professional astronomers not on her team looked it over and said that it was a new and meaningful piece of research on Kelt 2AB, a hot Jupiter transiting the bright primary star of a binary system. So Karen is in the business of discovering and studying exoplanets. You might say, what's an exoplanet? An exoplanet is a planet around a star that is not our sun. Currently, we know, well, 25 years ago, we knew of no exoplanets, none. It was science fiction, Star Trek. Now, we know of, roughly speaking, around 850 confirmed exoplanets, and about 2,000 candidates. It is a booming business, and we are finding that we have a very, very, very interesting universe indeed. So Karen is part of the vanguard of researchers investigating exoplanets, and so we celebrate her contribution to science. And I would like to add, actually, that Karen did her research, at least in a large part, at the Moore Observatory in Oldham County.
Yep, we're doing it right here in Kentucky. So,
okay, what size telescope did you use?
24 inches, so it's not huge, but we can find planets with it. So a lot of fun. Come join us.
And what did you have to do to the telescope and instrumentation to get it working?
Oh, lots and lots of work and lots of help from my professor, Dr. John Kilkoff. If he's here, thank you.
Okay, so this is an illustration of astronomy done locally, big-time astronomy done with a local telescope. So thank you, Karen. So we celebrate astronomy here at the University of Louisville. We have good undergraduates engaging in their studies. We have graduate students pushing back the frontiers of science. And we also, every year, invite a prestigious and renowned astronomer from another institution to tell us about the current state of research and knowledge in all fields of astronomy. This year, we have the honor of having Dr. Chris Stanek from The Ohio State University to come to talk to us about measuring the age and size of the universe. He did his undergraduate degree in Warsaw, Poland. He's a native of Poland. Then he came to the United States and did his PhD at Princeton. Went to do a series of 2 postdocs at Harvard University. Was one of them a Chandra?
Or Hubble.
Hubble. He had a Hubble Fellowship at Harvard University. Hubble Fellowships are very, very competitive. There are only between 10 and 15 given in any year. And if you have a Hubble Fellowship, it is a stamp of approval by the community that you have done good work and that you will probably continue to do good work. Afterwards, he stayed at Harvard as a faculty member and then moved to Columbus. I'm going to embarrass you to death here. Then he moved to Columbus to take up a faculty position at The Ohio State University, where he is now a professor of astronomy. So I hand it over to you, Dr. Chris Stanek.
Thank you. I think I have one.
Oh, okay.
Thank you. So the plan today is to cover about 14 billion years in 1 hour, but also about 2,500 years from the point of view of history astronomy, to cover how we actually came to appreciate how big the universe is, how complex it is. Now, of course, to learn really about the universe, you at least need a semester, maybe more. So here I'll concentrate on the issues with respect to how actually we measure the sizes, how we measure distances of objects in the universe. And this goes back to Greeks. They actually really were pioneers in kind of modern thinking. It is both modern and in some ways surprisingly also not modern. So they, they kind of had to invent things. And so I will discuss how Greeks already measured the size of Earth with very, very good precision, kind of knowledge that we then forgot and then we had to rediscover. But then the revolution in astronomy really was to discover that the universe is much, much bigger than the solar system. It might be infinite. And so this is something I want to discuss in this talk. And of course, always there's still plenty of things to discover. Science really isn't just body of knowledge. Science is what we learn, but more importantly, how we learn it. So this is also part of this talk, is to convey that, as I like to say at our morning coffee at SU, science is a process. We know there are blind alleys, you made mistakes, you write wrong papers, and that's very much part of the process. But you know, slowly, sometimes faster, we learn things about the universe. And you know, I just hope we'll continue to do so in the future. And so Edwin Powell Hubble, as I mentioned, he actually lived in Louisville, Kentucky for several years. Is the hero, one of the heroes of this talk. And this, I think, quite appropriate quote is that the history of astronomy is the history of receding horizons. Literally, universe, as we will find out, is expanding. So that's also, it's happening. The universe actually is becoming bigger. But also our understanding of the universe is expanding. What we think how big the universe is really always, the universe is always growing. And Edwin Hubble very much played a role in this on more than one occasion. And here he is smoking a pipe at the, I think it's a 60-inch in California. And of course the Hubble Space Telescope, which is still in space, running for now more than 20 years. It was named after Edwin Hubble. And I will discuss why. So the ancient view of the universe was rather simple. The Earth is in the center. And then depending who you ask, people didn't really have a model for how the planets would stay in their orbits. The Greeks, and even before them, other people realized there are these objects called planets, the wanderers, that don't stay put. They move among the stars. Sometimes they actually reverse their motion and go back. And so people had to, what we would give Greeks credit for, is that they actually tried to understand how these motions work, but they didn't really have a physical